For the last example, we're going to do one final problem, and it's going to be a chi-square. It's going to be a chi-square. Do you guys remember all the way back to the chi-square idea? What do we do? Emily, do you remember the chi-square thing?
Measure frequency.
Yeah, we measure frequency. I think we asked you how many of you hate statistics. Now, of course, it's unanimous. We all hate statistics except the instructor. But he loves bike riding anyway. So we asked how many people like statistics, how many people don't. We collected some numbers, 90 and 10. The idea is it's frequency based. So is there a difference in frequencies? And we compare that. What if I told you it was 100 people sampled and it was 90 and 10? What would we compare the 90 and 10 to? 90 people said they don't like it and 10 said yes. What would be chance there? If it was 90 and 10, what would be chance? 50-50. So we say, are these results different than chance? FO minus FE, da-da-da-da-da, and that kind of thing. So that's our 2-minute review of what we did previously with a chi-square. So now, for this example, let's see what I've created here. Two columns here. What does it look like these two columns are? Drew, what does it look like is going on in these two columns?
Score for depression and another one for family with history. I'm guessing that's a yes or a no.
Yeah, this is a yes-no situation. So the first thing you could probably write in the notes, this is a yes-no situation. Do you have depression or do you not? And is there a family history of depression or not? So these are two categorical variables. What do you think my hypothesis is? Beverly, what do you think the hypothesis is here?
That if there is a family history, there will be depression. If there is not family history, then there won't be depression.
Yeah, the prediction is exactly that. If there is a history of depression in the family, there should be a higher rate of depression for the offspring than if there isn't. So it's kind of a little genetic bit here. So we're dealing with frequencies here. Would this be a chi-square?
Yes.
Yes, it would. Is it a chi-square goodness of fit, though?
I would guess no. I wouldn't know how to construct the expected frequency.
Yeah, it's not a chi-square goodness of fit. What we're going to actually do for this last example, it's the other one. It's a chi-square test. Well, it's a chi-square test of independence.
Right.
It's a test of independence. Remember, I think I showed you some numbers for cancer and smoking.
Oh, it's been a while, but yeah.
It's kind of the cancer smoking game. How many people have cancer, how many don't, how many have smoked, how many have not. So it's kind of a 2-by-2 situation here. So actually, let's even draw it up as our last example. Did I lose my marker? Oh, there it is. Woo-hoo. All right, so let's make a little 2-by-2 here. So let's see, maybe on the top, we should write fam history. And we'll have 1 for, actually 0 for no, and 1 for yes. And then we can make the row, maybe offspring. The name for a variable. And we can have 0 for no, what? 1 for yes. So let's look at some numbers here. Go back to the data screen when you get a chance. Oh, people are constructing tables. I'll give you a minute. Don't worry, it's not like I'm going to Disneyland or anything tomorrow. Oh wait, shut up.
Why do you keep saying that? Do you want them to get jealous?
No, I'm just making jokes to try to be amusing.
Well, these jokes aren't funny. You keep
Well-
mentioning Disneyland.
Yeah, but my dad used to say to me, Stuart, you have two types of jokes. One where the jokes are actually funny and people laugh at the jokes. The other is where people are actually laughing at you, but they're still staying awake by doing that. So this is more type 2. But I don't know, they're kind of smiling and smirking there. Beverly, are you smiling and smirking there?
I was having a little trouble hearing you.
Okay, well that can only be considered a plus. Don't worry, these jokes aren't worth repeating. So let's look at the numbers here back on the data set. What have we got here? If you look at the data set there. So it looks like the first, how many numbers do I have there?
The first 10 are yes. And
So
the
for-
second 10 is no.
The first 10 are yes for depression, and the second 10 are no. I didn't really write the matrix up the right way here, but we'll get over that. So the first 10 are yes, they do have depression. So how many of those have the family history? How many of them also said yes to family history?
8,
What was it?
yeah. 8.
8. So if 8 said yes for family history, how many said no? 2, right?
Right.
How about for those that don't? For those that said no, how many of them had a family history?
3.
Is it 3? So how many of them were no and no? Should be 7. So how does that look to you? Does that look like it matters? Does it look like that matters? Does it look like family history matters? If you have somebody in your family who had depression, does it look like you have a much better chance of having depression yourself?
Yeah.
Yeah, it's like 80% chance, right? If you don't have somebody in your family, there's a 70% chance that you won't have depression. So it looks like this matters. It looks like this does indeed matter. So what we will do here is I'll walk you through the statistic on this one. This will be the last statistic we do. So go back to your data screen and I'll give you the steps here. Actually, you may want to do a copy and paste of those 2 columns into your Word file so you have it, so you know how it's created. Okay, so here we go, the last big statistic. Hope I haven't been recording too long on this. What do we got? No, I'm still good. Okay, so what you need to do is go into Analyze. I'm thinking about it for a second. Under Analyze, go into Descriptive Statistics. You may even want to write this down. Descriptive Statistics. And go into Cross Tabs. Cross Tabs. Go into Cross Tabs. And then you have to put the two variables in. So on the row, put depression. And on the column, put family history. We're almost there, and go click it on statistics on the top right. Click it on statistics. And under statistics, click on the chi-square. Statistics and chi-square. And then do continue. And then do OK.
Which ones should we copy?
I'll tell you in just a second. The first one you want to copy is where it says Depression Family History crosstab. Does that look a little familiar?
Yeah.
So it does it for you. So that's good news. And it looks like if you do have a family history with a 1, is it likely that you're going to have depression? Yes, it's the 8 number. And if you don't have family history, there's a good chance you won't. The second screen, go back to the data screen again, or the output screen, I should say. Go grab that, that second one, that chi-square. That whole table, copy and paste, that'll be the last table you do. And paste that in. That's a big, long table, isn't it? But there's only one line that's important there. What's the one line that's important there? Beverly, what's the one line that's important there?
The Pearson chi-square.
Yep, the chi-square. So you could write out a chi-square here. We're good, Em. Chi-square, if you want to write the x squared. X squared. Then in parentheses, it would be what? Degrees of freedom, which is what?
1.
1. So in parentheses, 1. Then n equals what? N equals 20. Close the parentheses. Equals what? What's the chi value? 5.05? Ah, here. We'll help out. Chi square. 1 comma n equals 20 equals, what is it, 5.025 or something?
5.05.
0.05. And then p equals what? What's the probability that's given there?
0.025.
Yep, 0.025. Is this significant or is this non-significant? It is statistically significant. What is the real-world conclusion? What is the real-world conclusion? This is statistically significant. Look back at the table.
If you have a family history of depression, you also have a significant chance of getting or developing depression?
Yes, that if you have a family history of depression, the likelihood of you having depression is much greater. So a family history of depression is indeed related to you having depression. If you know people who are depressed, many times there are relatives who are depressed as well.
Are you talking about like genetics?
Yes, because that's family history. I just made that example up I believe that's actually true, but I tried to create a data example that would be simple enough to understand. This is, why isn't this a chi-square goodness of fit? Chi-square goodness of fit is just how many variables? 1. Is this different than chance? This is not that. This is, does this depend on that? Does cancer rates, do they depend on smoking? So this is a chi-square test of independence. Okay.